Mathematical practice standards. What is a math practice standard? Well, the standards for math practice are a group of 8 Common Core or New Jersey Student Learning Standards for Mathematics. They outline the mathematical habits of the mind that students should develop as they engage in mathematical learning. These standards emphasize the development of mathematical thinking, problem-solving skills, and the ability to apply mathematical concepts in various contexts. They are intended to support students in becoming mathematically proficient and to prepare them for college, careers, and active citizenship. When teaching, active use of the standards with your students is key in their application. The mathematical practices being addressed within the context of the lesson can and should be shared with your students. In the courses you take with NJCTL, these standards appear as pull tabs in the presentations and video lessons wherever they are applicable to demonstrate their use. You will also be asked in various assignments and reflections about integrating the standards within your lessons. Some of you may be asking, where can I find the mathematical practice standards? Well, the following document is a useful resource for you to quickly look up all of the standards along with sample questions to address each one. So if you click the word document in the PDF attachment, it'll open a sample PDF with different questions in them. So it has each standard listed. So here's standard 1, 2, 3, 4, 5, 6, 7, and 8. And it has sample questions that help you ask students for more feedback and for participation within your lessons. Many schools require that the math practice standards are displayed in your future classroom for easy accessibility and use. Let's go over each standard in a little more detail. The first math practice standard is to make sense of problems and persevere in solving them. Students should be able to understand a problem, make a plan to solve it, and persist in finding a solution. This standard means that students can read and understand what a problem is asking, find relevant information within the problem needed to solve it, develop a plan for solving the problem, monitor as they work through solving the problem to be sure that their approach is viable, and change course if needed. So they're continuously asking themselves, does this make sense? And you can actually enforce that in your students, like as you're teaching them a concept and you're solving a problem, ask them while they're solving, or even when you have the final answer, does this answer make sense? Does it fulfill the requirements of this word problem? And then you can also relate the problem that they're solving to things that they've learned in the past or problems that they have solved in the past. In that linked file, you'll see here's Math Practice Standard 1. So sample questions are found here. How could you start this problem? What information do you know? What is the problem asking? Does the plan that you have to solve this make sense? Why or why not? How is so-and-so's way of solving this problem similar or different from yours? How can you check that this is reasonable? As explained, this standard will be used at various times in lessons, and these are just a couple of examples. When students are note-taking, they're going to be learning new material and new math language. This is a time to learn to make sense of problems that they are exposed to in order to understand what they ask. So the sample questions that I popped up with the last slide will help guide them along with that process. And when they're solving practice problems or class examples, students will use these practices to develop strategies to solve the problem and to persevere in solving them and finding the answer. We all learn math through our mistakes, and mathematical problem solving is a journey. It's not a single destination. As they continue to learn and grow in this field or subject area, they're going to find different strategies, and sometimes they'll like one strategy more than the other, and that is perfectly okay. Again, it's a journey, not a destination. The second mathematical practice standard is to reason abstractly and quantitatively. Students should be able to decontextualize mathematical situations and represent them symbolically, as well as make sense of quantities and their relationships. The use of this standard will come into play during various times in lessons. Students will read through problems and construct expressions, equations, mathematical sentences, etc., in order to solve the problem. Students also reason to determine if answers are logical versus impossible. For example, when you get a negative answer, but then you're finding distance, those negative answers could be called extraneous or extra answers that don't make sense. So when they're figuring out which answers don't make sense or are impossible, they're using that quantitative and abstract reasoning. Sample questions that you could ask them along the way while they're working through a problem or while the class is working on a problem together. What does the number blank, pull the number out of the problem? Like, what does the number 5 represent in this situation or in this problem? Can you represent the problem that we're given in symbols and numbers? Create a representation of this problem. How can we write this out? Mathematical practice standard number 3 asks students to construct viable arguments and critique the reasoning of others. Students should be able to justify their mathematical thinking and evaluate the reasoning of others in mathematics. This standard can be addressed easily with the following. You can ask students to share multiple approaches to solving the same type of problem. For example, if you had a problem that could be solved using repeated addition, that could be one method. Another method could be multiplication. You can also use mathematical practice standard number 5 when presenting formative assessment questions to your students and allowing for them to discuss the reasoning within their groups as they come up with their final answer for the group. Or when polling them individually, if you end up getting polling results that are closer to a 50-50 split, you can have students find another student that has a different answer than them and have them debate it out and see which method is better than the other and which answer choice is the final result there. You can also ask students to explain whether a solution is correct, and if it's not, how they find the error or how they know the reasoning is incorrect. Sometimes in classwork homework problems, even an assessment question or a formative assessment question, it will show sample work for how a student found an answer, and you have to explain whether or not the student is correct and explain. Those are classic math practice standard number 3 questions. And the last type is to request a verbal explanation of the steps taken when solving problems. Sample math practice standard questions that will help address the 3rd math practice standard are, how is your answer different from somebody else's? How can you prove that your answer is correct? What reasoning or properties do you have to help with proving that answer? What math language will help you out and prove your answer? And so on. Mathematical practice standard number 4 is about modeling with mathematics. Students should be able to use appropriate and varied models when solving problems and use mathematics to solve real-world problems. This means that students can think abstractly about problems to determine context and also quantitatively to solve the problem. They can simplify complex problems. They can determine ways to represent problems mathematically so that they can be solved. And they can use various types of models. Examples include, but are not limited to, equations, graphs, diagrams, and so on, and use them to solve the problems. When your class is working through examples, formative assessment questions, or even classwork problems that are application-based, these are great questions to ask them. Write a number sentence to describe this situation. What do you already know about solving this problem? Now, some of these also tap into one. So you could ask them, what is this problem asking? What do you already know about solving this type of problem? What connections do you see between this concept and this concept? Or multiple concepts? Why do the results that you found to solve this problem make sense? Is this working, or do you need to change your model because the original one isn't producing an answer that makes sense? Mathematical practice standard number 5 is to use appropriate tools strategically. Students should be able to choose and effectively use appropriate tools, including technology, in mathematical problem solving and reasoning. This standard often pairs with mathematical practice standard number 4. Once students have multiple methods to solve a problem, they will need to practice selecting and executing those strategies correctly. This can be done by comparing various methods and applying them to the context of the problem that is at hand. You can ask students which method works best for the scenario presented and why, and which tools would be helpful to solve the problem. Sample questions that would help address mathematical practice standard number 5 include the following. How could you use manipulatives or a drawing to show your thinking? That's a big one, especially in word problems. If you can draw a picture to represent what's going on, it helps them out so much more, especially when dealing with concepts that are geometrically based. Which tool or manipulative would be best to solve this problem? What other resources could help you in solving this problem? Mathematical practice standard number 6 is about attending to precision. Students should be able to communicate precisely in their mathematical work using clear definitions, accurate notation, and appropriate units of measurement. Clearly, accuracy in mathematics is important, for example, when rounding to the correct decimal place. The standard requires flexibility and attention to detail. Problems often require a different level of precision. Student adaptation to what level of precision is expected is as much a part of the standard as the precision itself. Some of you may be asking, how can this standard be addressed? Take a moment to pause this video and think about it, and when you're done, unpause it. The standard can actually be addressed in a couple of different ways. Teachers can help address this standard by rewording and changing instructions for solution requirements and problems. They can also emphasize number sense and units of measure in their answers. For example, when solving a word problem, if the units of measurement are, say, meters, you could ask at the end, well, what did we just solve for? We solved for a distance, we solved for a length. So what units of measure do we need to use here, and which ones make sense? They could always use the same units that are in the problem, or if they want to convert it to another unit of measurement that's accurate, they can definitely do that. Other ways to address attention to precision are with the following questions. What does the word blank mean? Why can you use this word, definition, theorem, postulate, etc. to justify that step in your proof? Explain what you did to solve the problem. Compare your answer to somebody else. Do they make sense? Do they match up? Why or why not? What labels could you use in your solution? How do you know your answer is accurate? Did you use the most efficient way to solve this problem? By the way, when we asked you to pause the video and think about the question on the last slide, we implemented mathematical practice standards number 1 and number 3. Mathematical practice number 7 is about looking for and making use of structure. Students should be able to recognize and use patterns and structures to solve problems and make connections in mathematics. This standard is satisfied anytime a numerical, graphical, or algebraic connection is made. Math is all about patterns and relationships among concepts, and it is vital that the students see those connections. To implement this standard, teachers can prompt students to think about ways a larger or multi-step problem can be broken down into smaller parts. They can find concrete ways to use general math rules to solve a problem. They can also think about how they can use what they already know to solve unfamiliar problems. Sample questions that can be used to address this standard are, why does this happen? How are these two concepts related to one another? You're trying to build that connection between one concept to another. Why is this important in the problem? What do you know about this concept that can apply to this situation and solve this problem? How can you use what you know to explain why this is a method that will work? Do you see any patterns? What are they? The next and last mathematical practice standard is mathematical practice standard number 8. Look for and express regularity in repeated reasoning. Sometimes mathematical practice standard number 8 will tag along with the previous mathematical practice standard, standard number 7. Students should be able to identify and generalize mathematical patterns and make conjectures based on repeated reasoning. Basically, this standard is asking students, is there a shortcut? How can you, or how do you, make a problem easier or faster to complete? It also asks students to attend to smaller details of a problem while also looking at the bigger picture of the problem as a whole. This standard can be addressed in the following ways. We can provide similar problems in different contexts and have students make connections between how to solve the similar problems. We can ask students how the answer to one problem can help them solve another one. And the classic example of mathematical practice standard number 8 is showing a longer form of an answer and asking the students to shorten it with mathematical symbols due to repeated patterns. So for example, when you're first introducing multiplication to students, you're usually teaching them repeated addition, like 5 plus 5 plus 5 plus 5 plus 5 plus 5. You wrote down 5 that certain number of times. When you execute the addition problem, you get a certain answer. Now, how can we shorten that? How many 5s did I actually add together? Could I multiply 5 by another number and get the same answer? With all of the information that's been provided about the math practice standards, many of you may be asking, well, what now? Now that you are more familiar with the standards, look out for them and how to use them within your math courses at NJCTL. They will appear when applicable within the presentations. A sample is shown below, displaying a tab that can be pulled out to identify which mathematical practice standards are covered and how. If you're opening it in either PowerPoint or Google Slides, while you're in present mode, you would have this slide appear first and the tab will be off to the right. And then when you press the next arrow or click on a mouse button, the math practice pull tab will then come out. So this is a sample from a second grade presentation. It's asking students to circle the digits in each number separately. And the mathematical practice standard covered is math practice standard number 6, attention to precision, making sure that the students understand and can explain the difference between a digit and a number. We will end with some food for thought. What mathematical practice standard or standards is or are being addressed on this slide? It is practice for making and writing of numbers. Pick your own number. Pull the base 10 blocks onto the chart to show the number. Then write the digits in the correct place under the blocks. Finally, complete the addition sentence that appears below. Take a moment to pause this video and think about it, and when you're done, unpause it. The use of the base 10 blocks to construct a student's own individual example emphasizes mathematical practice standard number 5, using appropriate tools strategically. So because we have these base 10 blocks, that is the main standard that is occurring here, but then it is also helping them with mathematical practice standard number 2, reasoning quantitatively and abstractly, mainly quantitatively.